I'm a civil engineer. I've done structural engineering. And as I was doing this civil engineering, I got good mentors who told me, hey, no, you can't just study one thing, how to design and construct roads, how to come up with structures of a storied building, like the columns, beams. All right? No, as you're doing this, be doing some other course by the side. So I was able to do CPA, and at the end of the day, I'm able to blend the two courses very, very well. So we ran a college known as the RCM College, which is the biggest CPA college in East Africa. Within RCM College, we have introduced RCM High School, which offers holiday tuitions to high school students. And that is why we are here today. And today I will be taking you through, ladies and gentlemen, I'll be taking you through great things here. I would want us, first of all, to go through geometry. Geometry, the concept of the circle. So assuming, ladies and gentlemen, you have got this kind of circle theorem here, we have here, what do we have? So we have, this is the center, and then you have the chord there. So here we have, in this case here, O. This is O, like that, all right? Then we happen to be having something going like that. This happens to be an isosceles triangle. So they want us to find X there. And then they have given us, or rather we have this. We have this angle, which is subtended there to the circumference here, all right? And then, ladies and gentlemen, they have given us this angle here as 88 degrees. 88 degrees, and then we are required to find the value of X. We find the value of X. I'm so sure you have done these concepts of quadrilateral, within a circle. I'm so sure you must be knowing some concepts here. All right. So is there somebody who will be able to shoot straight and tell us the value of X? Tell us the value of X. Angel has seen my videos. Yeah. So remember, there could be a possibility that some of you have not yet done these concepts, but you are here to learn. So I'll not be able to answer that question like this is coming from which form. We are here to learn. Everybody will be learning here. Everybody will be learning here. All right. So remember, ladies and gentlemen, we have this chord, which is able to sustain an angle at the center and an angle at the circumference. Angle at the circumference. If you are able to remember this very well from your class tutorials, you are told something very nice here. Allow me to just draw something small here. So if we have the center here, and then we have this one here, like that. You are told that there is a clear relationship between these two angles. There is a clear relationship between these two angles, so long as they're coming from the same chord, one to the center, the other one touching the circumference. The relationship between the two is that if this angle here is X, then this angle here will be 2X. Is there somebody who is able to remember this concept here? That the angle at the center will always be equal to 2, the angle of the circumference here, this angle of the circumference. So angle at the center will be equal to twice angle touching, let me just call it at circumference. 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 Is there somebody who is able to remember this concept? Great. This is the angle at the center. It's normally bigger. The angle subtending to the center here will always be equal to double the angle at the circumference. So then if that is the case, this is the angle at the center. We expect this angle at the center to be double the angle here. Allow me to call this one here Y. I can't call it X. I can't call it X, ladies and gentlemen, simply because we have an unknown X here. And we are saying that the angle at the center, which is 88, will be equal to twice the angle at the circumference. Twice the angle at the circumference. All right? So is there then somebody who can give me the value of y? Divide both sides by 2. Remember, I'll be giving very good presents as we continue. Divide both sides by 2. If I divide both sides by 2, then I will end up getting y equals what here? 44 degrees. So y equals 44 degrees. Y equals 44 degrees. Y equals 44 degrees. Y equals 44 degrees. And then, ladies and gentlemen, remember this is what we call a quadrilateral. Quadri because of what here? 4 angles, 4 corners touching a circle. 4 corners in this case that are touching a circle. Then we have another rule. We have another rule of the opposite angles. Opposite angles. Opposite angles of a quadrilateral. Opposite angles. Like now we have this and this. They are opposite. That whenever you add the opposite angles, they must always give you a total of 180 degrees. The concept of opposite angles. So opposite angles, whenever you add them, they must give you a total or a sum of what here? A sum of 180 degrees. You see, these are opposites. So we are saying that opposite angles, x plus y, but you see, we know y. We know that y is 44 degrees. If you add the two, we should be able to get 180 degrees. And therefore, x will be equal to, make x the subject of the formula. Let, in this case here, this 44 go to the other side of the equal. Here it's positive. When it crosses over the other side, it becomes negative, yes. So it will be 180 degrees minus 44 degrees, which I'm able to see somebody giving me a figure of 100 what here? 36. So then you have been able to answer the question. So x is 136. I'll be able to give you guys an exam. By the end of the session, I'll be giving you 3 questions. If you get them right, then you'll be able to get a great present. Ensure that you are learning. Whether you have done this in your class or not, that's a non-issue. The thing is that we should be able to gather new knowledge and apply it today to be able to get a great present today. Is there somebody who is ready for my presence today? Are you ready for my presence today? Yeah, it's about learning. It's about learning. You should not fear anything. Don't fear anything. And remember, for you to get my very best presents, like Kenya shillings 1,000, then you have to invite your friends. As we continue, we expect you to invite your friends. And also, remember that you are free to ask questions. You can just type there. You are free to ask questions as many times as possible, and then I'll be able to do what here too? Respond. Ladies and gentlemen, let's continue here. Now, today I only want to teach you like 3 concepts of this geometry, of these angles, only 3 concepts. You'll be able to get a question like this, all right? So you have a question like this. You are told that these 2 lines are what here? Those 2 lines are parallel. Those 2 lines are parallel. And then we have a transversal. A transversal line. So these 2 are parallel, and then we have a transversal line. And then now what will happen? This is quite a simple question. Parallel means, of course, they will never meet. All right, going to the same direction, they will never meet. All right, and then we have a transversal line. And then we'll be given here like this angle. Somebody will tell you this angle is 30 degrees, for example. So is there somebody who can give me the value of angle x? Is there somebody who can give me the value of angle x? Admin has a question. Please go ahead and ask. Don't worry. Yeah, 30 is correct. 30 is correct. Why? Because of what here? Do. Alternate. You can see this one is like when you're walking, alternate. So this angle and this angle are alternate angles, and alternate angles will always be the same. Alternate angles will always be the same. So you're right. This x will be equal to 30 degrees. Why? This angle and this angle, they are what here? They are alternate. Like alternate angle. They keep on alternating. They alternate like this. Is that clear? Is that clear? So then I'll be able to unmute you later on. Now, ladies and gentlemen, please listen. Then how do you apply this in your mathematics paper 1? I've been able to pick a question from your mathematics KCSE simple questions, which you shall always get right. Always, you shall always get right. So assuming you have a triangle, all right? So, and in this case here, this triangle, we have something like that, all right? And then we have something like this, all right? And then they are telling you that this line and this line, they are parallel. So they have given us here 80 degrees, all right? No, sorry for that. So they have given us here 80 degrees, and here we have a 60 degrees. And then we happen to be having X here. We happen to be having X there. So we are required to evaluate, we are required to give these people the value of X. The value of X, given the concept of parallel lines. This and this are parallel. They're parallel. So is there anybody who can give me the value of X? Somebody has already gotten 40. Yeah, 40. Thank you so much. 40. You guys are good students. 40 years. 40 years. Why? Because, you know, this is parallel to this one. And if the two are parallel, then we expect alternate angles. We expect alternate angles to be the same. How do we identify these alternate angles? Remember what you are told in your normal class. If you have this line and this line being parallel, and then you happen to be having a transversal, like this is a transversal, a line that is cutting across the two. For you to be able to identify alternate angles, always look for the Z kind of a figure. Z. You see how Z looks like this. So this is parallel to this. So, and you can see Z. So these angles of Z, these are the same. Those angles of Z are the same. So if you look at this very well, if I try coming up with my Z, then I'll be able to see these alternate angles. So I'm being told, ladies and gentlemen, that these two are parallel. So where is my Z kind of a shape? Kind of a shape here. So Z will look like this. Quite a funny Z, but you can see it. Because this and this. So the transverse is here, and you can see my Z. So when you see my Z very well, then the elbows, you're able to see the elbows here, the inner side of your elbow, of the Z. So you can see in this case that this 80 and this angle here are alternate. So it means that this will be 80 degrees. That will be 80 degrees as well. So then if that is the case, we know now that this is a triangle, and all angles of a triangle added together will always give us what here? Will always give us 180 angles in a triangle. Internal angles of a triangle. Internal angles of a triangle. The sum will always be equal to 180 degrees. So then you come and add the 3. So you're saying that 80 plus 60 plus X should be equal to 180. So this plus X should be equal to 180. All right? So 80 plus 60 is 140 plus X equals 180. Take the 140 to the other side. Here it's a positive. There is an invisible positive here. So on the other side, it will be a negative. So it will be X equals 180 minus 140, which gives us what here? 40 degrees, like that. 40 degrees, like that. Yeah, we collect the like terms. Thank you very much. So X equals 40 degrees. X equals 40 degrees. So, ladies and gentlemen, up to here, is there somebody who has been able to pick some concept here? Is there somebody who has been able to pick some great concept that now they can apply? Remember, as we continue, I'll be coming up with complicated geometry, complicated angles. But the moment you get the base, the concepts right, then you can never ever go wrong. All these ones you'll be getting everything 100%, 100%. So is there somebody who can give me this value of x? Anybody who can give me this value of x? Remember, this is a triangle where we have an extended exterior angle. There is an exterior angle. Yeah, most of them are able to see, really, this is very, very easy. This is very, very easy. This is really, really easy. Because remember exterior angle. Anytime we talk about an exterior angle in a triangle, like now this is an external angle, external out there, this will always be equal to the sum of opposite angles, opposite internal angles, opposite internal angles. So this exterior angle here of 100, it will be, you see this one here, opposite angles, internal. The opposite, you see, opposite of this is 60 and x. So when you add the two, then we should be able to get an equivalent of this. So exterior angle will always be equal to sum of opposite internal angles. So 100 will be equal to 60 plus x. Therefore, x will be, make x the subject, take this 60 the other side. Here it's positive, on the other side it will be negative. So 100 minus 60, this will give me 40 degrees. You must always write like that, the final one, 40 degrees. That is a method number 1. Method number 2, somebody can easily make use of the supplementary angles along a line. Angles along a line must always add up to 180 degrees. If you're given angles along a line like this, even if there are 10 of them, it doesn't matter. Angles along a line, when you add them like this, they must always add up to 180. So the same concept of this, like this, will be applied here, because this is a straight line and we only have 2 angles. We only have 2 angles. So it means the 2 angles must add up to 180. The 2 angles must add up to 180. And if that is the case, it means that this angle here will be 180 minus 100. So this angle here will be 80 degrees. Because angles along a line, along the same line, must always add up to 180 degrees. All right. And now once I've been able to get these 2 internal angles of a triangle, I will easily get x, because I know that internal angles of a triangle must always add up to 180. Internal angles of a triangle. Internal angles of a triangle must always add to 180. Very important. So come and add the 3. So it will be x plus 60 degrees plus 80 degrees equals 180 degrees. Put like terms together. First of all, start with this and this. Combine them. So x plus 140 equals 180. Take 140 the other side. So it will be x equals 180 minus 140, which gives me 40 degrees. So x is 40 degrees. Thank you so much, Marcelo. Thank you so much. Thank you so much. Thank you so much. So this will be my base for discussing with you, great students of mine, the concept of what here? The concept of angles. The concept of angles, and everybody will be excellent, given that now you'll be learning these angles from a civil engineer. I mean, you guys will become so good with geometry. Nobody will ever have a problem with geometry. And remember, we happen to be having these holiday tuition classes, which are doing wonders. Many students have been able to benefit over the number of years that we have done the holiday tuitions. We have been of help to so many students. So we normally charge Kenya shillings 4,000 for 6 papers, for 6 papers. That is from junior grade 9, Form 2, Form 3, and Form 4. All right. Once you pay the 4,000, then you'll be able to enjoy 6 papers. And we don't combine students. We normally handle specific classes differently. Like we have a class for junior 9. We have a different class for Form 2's etc. So if you're interested in our tuition, please talk to your parents and they will be able to do what here. They will be able to pay for you, to pay for you. That is our number, 0719 525,000. Now, I go on to the next question. The next question now is also an eye-opener. So you're told here to expand x plus 2 into 2x plus 3. Very easy. 2x plus 3. Can somebody in this case here do this expansion for us? Yeah, thank you so much. Can somebody in this case here do this expansion for us? I don't know whether junior 9, they're also doing expansion, but we've said we are here to learn new things because apart from, of course, the present we will get, we want to develop ourselves. When you want to develop yourself, you must always be open up to new knowledge. You must be open to new knowledge. So you're told to expand. Yeah, and Angel will be able to show you how it's done, yes, to expand. So remember when you're expanding, basically you're supposed to take this, multiply with this, plus this multiplied with this. You hold on to this x. Then you continue like that. You come and take now 2 multiplies this, and then this 2 multiplies this 3. I have no idea how to do it. I'll be able to show you, admin, don't worry. It's very easy. Basic expansion here means that you come and take, in this case here, this x, multiply with each of the 2 terms. So we have here, if this x multiplies this, what shall we get? We shall get 2x squared. And then you come and take the same x, the very same x in this case here to multiply this other term in your expansion. So then we have here x multiplied by this, it will be 3x. All right. Now we are through with the x multiplications. Now from there we come and take these 2 multiplications. Now 2 will multiply this, 2 will as well multiply this. So plus, so we have these 2 times 2x. So that will be 4 what here? 4x. Plus 2 times 3. 2 times 3 gives me what here? 6. Gives me 6. Thank you very much, admin. You're really a good student. Yeah, really good student. So then at the end of the day, put like terms together. So this will be 2x squared plus 7x plus what here? Plus 6. A bad method. This is not the method that we do this kind of a question using. This is not a method of, for engineers. Engineers will always be very creative. All right. So if I'm told in this case here to expand this, I'll not do this question this way. No. What I will do, ladies and gentlemen, I'll simply make a small table, method 2. Now this is a method for geniuses, for engineers, yes. So I will come and write here x2 like this. And then I write here 2x and then 3 like that. I'll make a table like this. I will make a table like this. For expansion, I will make a table like this. And then now we have here, this is number 1, this is number 2, this is number 3, this is number 4 like that. So now you come and give us multiples. So for square 1, I'm multiplying this one and the 2x, square 1. So x and 2x. So when you multiply those two, you'll get what we call 2x squared. And then square 2, you can see what is emitting. So square 2, I'm taking this x and the 3. It is x and the 3 which are emitting here. So x times 3, so this gives us 3x. 3x. You come to square 3. So square 3, look at the externals that are emitting. So we have these 2 and these 2x. So that gives us what here? That gives us 4x. Then lastly, we have in this case here number 4, externals meeting. It is 2 versus 3, which gives me what here? 6 like that. just 6. And then now you go ahead, leave out the externals, consolidate the internals, putting like terms together. So the expansion basically will be, you can see this doesn't have any like term. So then this one will be 2x squared plus, of course, these two, you can see they are like terms. You add them, you consolidate them. So 4x and 3x. So this gives me 7 what here? This gives me 7x like that. So I'm through with this. I'm through with this. 2 because I've added them. And then we have here this one left alone without a partner. So you just bring it like that. And you have finished your expansion the engineer's way. The engineer's way. The engineer's way. Yeah, I will repeat, yes. Let me repeat. Let me repeat. Very good. Let me repeat. Let me repeat. Let me repeat. Let me repeat. So somebody tells you to expand. Always expansion of these. Simply come and do. So this is x. This is 2x. No. Just x and 2 for this term. Yeah, and for this expression, we have 2x, and then we have 3. And then now somebody tells you to come and give us the multiples using the externals. So this will be 2x times x, this one here, because it is this external with this, giving me this cell. This cell is 3 versus x. So we have here x times 3, x times 3. Come here. So here, what do we have? Here, what do we have? So here, what do we have? So here what we have, it is this 2 versus this external. So 2 times 2x. And then lastly here, the external here is 2. The external here is 3 times 3, like that. So then if I go ahead and multiply, this will be 2x squared plus 3x, or rather, no, just 3x like that. And then we have this is 2 and 2. This gives me 4x. And this gives me 6 like that. And then now you put like terms together. Put like terms together. So when you put like terms together, what will you be able to get? Internals only. So the expanded one will be 2x squared plus. This has a like term. This has a partner. So 4x plus 3x. This gives us 7 what here? 7x plus 6. That is the end of that question. That is the end of that question. So is that okay, ladies and gentlemen? Is that now, does this make sense? Does it make sense? All right. Thank you so much. Thank you so much. Thank you so much. Thank you so much. Now, ladies and gentlemen, at times you'll be given very simple questions. Remember, in KCSE, it's all about practice. And don't wait until you are a Form 4 for you to be able to start practicing. No. Practicing normally of mathematics should start from Form 1. Once you enter Form 1, start practicing, because as you progress, what happens? You do not have time in future which will be able to redeem. Don't be cheated that if, for example, today, if, for example, in your class you are 20, and then you're becoming number 18, you keep on thinking that come the other term, or come next year when you will be in Form 4, you will recover. It will be very hard. All these 20 students are thinking like you, and they're going to work harder than yourself. That is why you need to start working very hard from today. And mathematics is all about practice. Like, the questions that you've done today, ensure that you do them almost immediately. After the class, you do them almost immediately, and then they become parcel of you. All right? You will never go wrong. Mathematics is all about what you've been taught in class. You should not sleep without reflecting. So if, for example, you have your teacher today, like myself, who has taught you for 45 minutes, he has done a few arithmetics here and there, before you sleep, if you're a boarder, just get time and review. Look at what your teacher did. Try to ask yourself whether there are other easier methods of doing this. Especially when you are in a class setup and you have very good social skills. Social skills means that you have friends within your classroom. You simply ask. You'll get somebody. Let me tell you, I've taught for so many years, but I know that there is nobody who has got monopoly over knowledge. You'll always get even some students who are even here. Some students could be better than myself by far. So there are those concepts that you can easily get much better from your colleagues, like that. Yeah. So for you to be very good in mathematics, practice is of essence. And then most importantly, there is the concept of learning from others, teaching others. Learning from others, also you have to teach others. You will come to thank me. And for the students who are in Form 4, it's not late. If you start practicing, get good mathematics books, start practicing like from today, and then have a good attitude. Start, in this case here, opening up to your colleagues. Tell your colleagues, hey, how comes I don't understand this concept of matrices very well? Become social. Human beings, we are supposed to be social in nature, all right? Yeah, have so many friends in your class. Ask them questions, At the end of the day, you'll become an expert. It's all about how you look at this thing. Trust you me. It's all about how you look at this thing. If you think mathematics is very hard, it's going to be very hard for you. Very, very hard for you. But if you are a good student who knows that mathematics is all about practice, how do I practice? I start with what I've been taught today. If, for example, we did some mathematics and I got, for example, a D plane, some paper we did like last semester, maybe you got a D plane, D for dog. No problem. Just go and ask yourself, these questions that I never got right, where did I go wrong? Discuss them with your fellow students. Never be that kind of a student who pretends to be very smart. No, there is nobody who is very, very smart in this world. No. Go and tell your colleagues, this question, I never got it right in an exam. And even now, outside the exam room, I can't get it. Please show it to me. And this person will be able to show you how to do it. And then, of course, it becomes part and parcel of you. Now you become very good. Yeah, so you need to open up to your colleagues and then, of course, practice with good attitude. You can never go wrong. Now, ladies and gentlemen, another question here. If 16 raised to 3x minus 1 equals 1, find the value of x. Find the value of x. Looks very simple, but there are some students who have not up to date understood the concept of any number raised to 0. Any number raised to 0 is 1. Any number raised to 0 is 1. Any number raised to 0. So like now what I would want to do is to make the bases to be the same. So how do I bring up this base to be the same with this? So I have to introduce 16 here. So then these will be 16 raised to 3x minus 1 equals 16. But because I want it to be 1, I will say it is equal to 16 raised to power what here? Power 0. Because any number raised to power 0, please try this in your calculator. Please try this in your calculator. Just try this in your calculator and then advise me. Simply go to your calculator and say 16 raised to 0. I hope you are able to see the raised function. 16 raised to 0. 16 raised to 0. 16 raised to 0. Is there somebody who is able to confirm to me it from your calculator? 16 raised to 0 equals who? Yeah, it will be equal to 1. Any number, be it 1,000, be it 1,000,000, any number raised to 0 will always be equal to 1. That's why we have changed this 1 to 16, but 16 as a base, we raise it to power 0. And now since the bases are the same, then 3x minus 1 will be equal to 0. I want to have it x alone to make x the subject of the formula. So take minus 1 to the other side. So it will be 3x equals 1. Because this is minus 1, on the other side it becomes positive 1. Implying that x will be equal to a third. X will be equal to a third. So the big take home from this is the fact that any number that is raised to power 0, any number that is raised to power 0 will always be equal to what here? Will always be equal to 1. Will always be equal to 1. Understood? Thank you very much. Now, using the same concept, ladies and gentlemen, how about this one? So this one, they have told us to find n. Now, this one, you guys should be able to do this one as I now give you the test, because I have to give you the test. For me to be able to give you a present, I must give you a test. I must give you a test for me to give you a present. Find n. Find n if logarithm of 4 to base 2 plus logarithm of 7 to base 2 minus logarithm of n to base 2 equals 1. Find the value of n. Yeah, somebody wants me to repeat the first one. Unfortunately, I've wrapped it. What I will do, Alvin, I'll be able to share this video recording with you. Yeah, I have a YouTube channel. I'll upload this immediately to YouTube, and then I share it with you, right? And then you watch. Should you have a problem, then you should be able to call me. I'll give you my personal number, all right? Yeah, you can always text me. But if you want to make inquiries about our school, about our online tuitions, this is the school's number, but this is my personal number. All right. Oh, I see there are so many guys. So find n if logarithm of 4 to base 2 plus logarithm of 7 to base 2 minus logarithm of n to base 2 equals 1. Find the value of n. N is 14. Somebody is saying n is 14. So the students who are in grade 9, have you done these kind of questions in your classwork, logarithms? Oh, no. Okay. You shall be doing this. You can see somebody has done it already. You shall be doing it. It's in your course outline. It's in your syllabus. So I'm just opening up your eyes to this quite early, quite early. Hart says n is 8, n is 8, n is 8. Jedi Jabal, we shall overcome. Don't worry. You'll be able to learn some new concept here. Annette is saying that this is 14. Okay, now before I do this, ladies and gentlemen, I would want to just jog your minds a little bit. Allow me to jog your minds a little bit. Remember, log is a short name for what we call logarithm. 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 Do we have our calculators with ourselves? Do we have our calculators with ourselves, ladies and gentlemen? Because you must always work with your calculator, always. A mathematician shall always work with their calculator, regardless of wherever they are. Yes. So can somebody in this case here tell me, what is log 10 plus log 20? In your calculator there, you'll be able to see logarithm. So go there and say log 10 plus log 20. Log 10 plus log 20. What answer are we getting from our calculators? What answer are we able to get from our calculators? Logarithm, you simply punch there log 10 plus log 20. You get it right, I will be very happy. So according to Alvin, he's getting 2.301. 2.301. 2.301. 2.301. 2.301. 0. 0, like that. All right, admin, thank you very much. How about this one? This one, I'm so sure you won't get it right. Log 200. Log 200 will be equal to what? Log 200. Log 200. They're not giving me answers now, you see. They're not giving me answers now, you see. It is the same. They are telling me it is the same. Now, I want to introduce to you some mathematical rule on logarithms. Mathematical rule on logarithms. Some mathematical rule on logarithms. Very, very important. That these logarithms, if, for example, you have here log 10 plus log 20, and then somebody tells you, hey, can you kindly factor out logarithm term? That I can factor out logarithm term, and when I factor out this logarithm term, I can't now inside here say 10 plus 2. No. When I'm factoring these out, when I'm factoring this logarithm out, and we happen to be having a plus, the plus will change to multiplication. It's a very, very important rule of logarithm. So in this case here, then this will become logarithm. You see, it was 10 plus 20, yeah? But when I'm factoring out log, there is a very important concept that when this log is factored out, the place of a plus will be taken over by what here? By multiplication. So it will be log 10 times 20, which will be the same as what here? Log 200. 200. And this log 200 now will give me 2.3010. Please listen. This is very, very important. You will get a situation where your examiner will give you something like this. For example, your examiner could give you log mn. Log mn. And he expects you to expand this. If he expects you to expand this, if your examiner expects you to expand, it means that the m should have its own log and the n should have its own log. So when I'm expanding, then this log mn will be log of m. Now, because here we have a multiplication implied. So now that I'm looking at them independently, so multiplication, now straight away when I introduce log, now we'll talk of what here? Plus. I will talk of log plus log n. Now, please listen to me, my students. Listen and listen to me very well. Listen and listen to me very well. You see, you'll have something like log 25 from your calculator. What is logarithm 25? Can somebody help me here? What is logarithm 25? Something very, very special is boiling here. What is logarithm 25? 1.3994. Thank you so much. 1.3994 like that. But do you know that 25 is the same as 5 squared? Do you know that 25 is the same as 5 squared? Yes. So then it will be the same as log 5 squared. So then can you kindly tell me what is log 5 squared? Please, everybody is punching in their calculator. Everybody, because there is something they're learning here. This is where my present will come from. Log 5 squared. Is it the same? Log 5 and then square. Same as this. Great. Thank you so much. So you see log 5 squared is the same as saying log 5 times 5. You see 5 times 5. Now I want you to do me a favor. I want to introduce individual logarithms into each of them. Individual logarithms into each of them, such that I talk of log 5 and then log 5. Log 5 and then log 5. If I do that, this will be log 5 plus, because now I'm expanding. So instead of multiplication, now we shall use what here? Plus. So it will be the same as log 5 plus log 5. I replace the multiplication with a plus. Can somebody in this case here try from their calculator, what is log 5 plus log 5? What is log 5 plus log 5? What is log 5? And then again plus log. There are students in this case who don't have their calculators. I should go talk to their parents for their parents to buy for them, in this case here, calculators. Log 5 plus log 5. Is there somebody who is able? We'll take the answer. Is there somebody who is able to get that 1.3979? Yes. Yes. Now please listen. Please listen. Something very interesting is happening here. You see, in logarithms, when I have like this log 5 squared, do you know that these two can also come to this side? Do you know it too inaweza shuka chini? Are you aware kwamba itu inaweza shuka chini na bado upate the same answer? Are you aware? Yes, that's a very, very important function of log that you can come and talk of 2 logarithm 5. So can you kindly do me a favor? Say then your calculator 2 logarithm 5 and see whether you're getting the same answer. See whether you're getting the same answer. 2 logarithm 5. Are we getting the same answer? Oh, it's not 1.3994. Sorry for that. I'm being corrected here. Thank you for that. Yeah, it is the same, isn't it? It is the same. So we have multiplication rule for logarithms. We have what we call multiplication rule for logarithms. And then we have, ladies and gentlemen, something very important called, in this case, the quotient rule. If, for example, somebody gives you log 100 here, minus log 90, can somebody in this case here give me this figure? Just go there in your calculator, say log 100 minus log 90. Log 100 minus log 90. Tell me what are we getting, somebody. Now I'm subtracting this time around. Log 100 minus log 90. Now I'm subtracting, ladies and gentlemen. Log 100. So I'm being given a figure of 0.0458. 0.0458. Thank you so much. And you are told in high school, you are told by your teachers that whenever you have a minus here, you can come and factor the log out. You can just have one log. But this time around, instead of minus, what are we going to do with this 190? We divide. We divide. We divide. So can somebody in this case here say logarithm of, you can even put this in brackets, logarithm of, open brackets, 100 divided by 90, you close. You close. Tell me what are we getting, ladies and gentlemen. It will be the same answer. And ensure you're using brackets. Ensure you're using brackets. And ensure you're using brackets. It will be the same. It will be the same. It will be the same. So if then that is the case, please listen and listen and listen and listen to me very well. Listen and listen and listen to me very well. For me to be able to get this n very well, what I will do, I'll simply come and factor log 2 out. When I factor log 2 out, what am I going to have, my friends, here? I will have here 4 because I'm factoring out. So this plus now becomes what here? Times. Plus becomes times 7. And then, of course, we have this n, because of the minus. What do I do? Because of the minus, what do I do here? Because of the minus, what do I do? No, they're not talking to me. They have to talk to me. Because of the minus, what do I do? Because of the minus, I divide, isn't it? So I divide this by n, like that. So I'm writing just one logarithm outside. So here I will have multiplication because of what here? Plus, and I divide here because of what here? Negative. Now, there is something that I would want you to tell me. Anytime you see a logarithm of a number to the same number, logarithm of 10 to base 10 will be equal to what? Logarithm of 10 to base 10 will be equal to what? Somebody talk to me. Logarithm of a number to its base, to the same base, will be 1. Will be 1. So if you see, for example, logarithm of 100 to 100 to base 100, this will be 1. So I would want this to be written in the form of log 2. This one, I would want this one to be written in form of log 2. Can somebody talk to me this morning? So instead of writing 1 here, I would want this to be written on the basis of log 2. How will I write this? How will I write this, somebody? That 1. This 1. I want to write it in the form of base 2. How shall it appear like? How shall it appear like? How shall it appear like? So that 1, I want it to be something to base 2. I want it to be something to base 2. Pata potea. Great, great. Thank you so much. So then this one here will be the same as log 2 to base 2. So basically log 2 to base 2 is exactly equal to 1. Is exactly equal to 1 is exactly equal to 1. So this log 2 to base 2 is exactly equal to 1. And because the log to base 2 are the same, log to base 2 are the same, we can cancel them. And then now we make n the subject of the formula. We can cancel them because they are on opposite sides. Log 2, we cancel them. We cancel them. All right? So when we cancel them like that, and then of course body mass, 4 times 7 is 28. So this is 28 over n equals 2. So cross multiply. Of course, there is a 1 there. Cross multiply, there is a 1 there. So when you cross multiply, what shall we end up getting? So then these will be 2n because I'm cross multiplying. On the other side equals 28. Therefore, n will be 28 divided by 2. So 28 divided by 2 will end up giving us a what number? Yeah, admin, I can as well do it the way you are doing it there, which is very good. So 28 divided by 2 will end up giving me what number here? This will end up giving me 14. This will end up giving me 14. And now that marks the end of our today's session. What I will do, I will send a homework. I'm so sure we are together in some WhatsApp group, isn't it? We are together with you in some WhatsApp group. So that homework will have 3 questions. The students will be able to get them very fast. The first 10 students, I will be able to give them a present straight away in that group. Otherwise, it has been a pleasure hosting you this morning. And I'm so sure that you guys have also been able to get something out of my teaching, however small. However small. For the students who are following me on YouTube, of course, we are live right now on YouTube, and ensure that you are hitting that subscription button, and ensure that you are commenting down there, and most importantly, ensure that you are sharing this link with your enemies and your friends as well. Should it be the other way around? Friends and enemies. Otherwise, I would also want to welcome all of you to our tuition. Ensure that you are part and parcel of our tuition. You can never go wrong. You can never ever go wrong. 0719 525 000. That is the number you need to call. Pay Kenya shillings 4,000. No, we shall be able to give you a pay bill. Pay 4,000 Kenya shillings, and then we put you into our paid group, so you'll be able to get videos, access to Zoom classes, etc. Otherwise, much love from me to yourselves as your father. Bye-bye. Bye. Or somebody has a question. Sorry.